Today our lesson is on ratios. A ratio, by definition, is a comparison of two quantities. And I say quantities instead of numbers because sometimes we'll be using variables. There are two types of ratio. There are the part-to-part ratios and a part-to-whole. A fraction is a part-to-whole ratio. Let's use an example. We're going to use 10 girls and 8 boys in a class. And there are 3 ways to show a ratio. For example, the ratio of girls to boys. The first way is to use a colon, 10 to 8. The second way is 10 to 8 using the word TO. And the last way is to use the division sign, 10 to 8. But be careful on this last one, as this is not really a fraction. It is a part-to-part ratio because we're using part of the class compared to another part of the class. So what is the whole in our example? The whole is the class, made up of boys and girls. And so one part is the girls, and one part is the boys. Alright? So a part-to-part ratio of girls to boys would be 10 to 8. But a part-to-whole ratio of girls to the whole class would be 10 to 18. And when we put this in this form, that really is a true fraction because it's 10 out of a whole class of 18. Continuing with our example of 10 girls to 8 boys in a class, let's look at how we would express those ratios. Girls to boys. So the number of girls is 10, and the number of boys is 8. The next one, however, we express in a different way, boys to girls. So boys to girls. And notice here that whatever is mentioned first, the number goes first. Here girls was mentioned first, so the number goes first. Boys was mentioned second, the number goes second. And vice versa in this one. Boys to the class will now be 8, as boys is mentioned first, to the whole class of 18. And in our last example, the class is mentioned first, which is a total of 18 students, to girls, which is 10. Now, let's use another example. This time we've got M&Ms. We have 5 red, 4 green, 3 orange, and 6 brown M&Ms. And the first thing you want to do on these is to figure out what is the total. Well, here our total is 5 plus 4 plus 3, 12, and 6, 18. So our total number of M&Ms is 18. So red to orange. Alright, so red to orange we have 5 to 3. Okay, the next one we have brown to green. Brown is mentioned first. 6 to 4. Green to brown. Again, we have to turn these around because they're mentioned in a different order. 4 to 6. Now this one's a part-to-whole. Red to the total. We've already figured out the total is 18. So red, 5 to 18. Our total. Now the last one is slightly different. And we will do, as I say, a lot more of this in probability. We want red, orange, and red to the total. So orange and red combined makes 8 to a total of 18. So that one was slightly different. We can also combine them. We can have some that are not orange. And again, we're going to talk about those when we get to probability. We can make equivalent ratios, and these are like equivalent fractions. Going back to the girls to class. Girls, 10, 18 in the class. This ratio is equivalent to 5 to 9 because both of these were divided by 2. So it's just like fractions. We have to do the same thing to both numbers. And in this case, it is a true fraction because it's a part of the whole thing. And if we divide it by 2, both sides, we would get 5/9. So those two ratios are equivalent. Ratios are used in a lot of different applications. We use them a lot in recipes. We would say we have 2 cups of sugar to the whole recipe. If we wanted to double that recipe because we need more or half the recipe, then we're going to use the equivalent ratios to do that. Sports statistics. Many sports have a lot of statistics. We're just coming into baseball season, and they have all kinds of statistics from batting averages to everything else. All of the sports include these type of statistics. Also, scale drawings and models. Anything that is built or made will have a blueprint or a drawing made of it before it's made. And so those will be to a scale. A ratio is used. Same with maps. Maps are a scale drawing. We use a ratio of maybe 2 inches to 1 mile. We also have models. We can make models of buildings, and I don't know if some of you have seen that. But a lot of the times when cities are making new buildings, they will produce a model of what the thing's going to look like. Probability. We will use ratios to find out the likelihood of an event happening. We've talked a little bit about that, about the M&Ms, which we will use in probability. The exchange rate of money. When you go to another country, then you will get so much of their money to each dollar. So that's a ratio also. And then there are many scientific applications. So I hope this has been an introduction to ratios for you. Make sure you have these things in your notes. And when we get to class, we will do a lot of examples with these. And you will start to see how some of these use ratios in different ways.